Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of parent functions. This is standard A.7C in the great state of Texas, and we are using item number 24 of the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got the graph of f of x equals x squared. All right, so that's going to be what we would call our parent function. Is just the most vanilla quadratic function you can think of. F of x equals x squared. We're going to transform it, and we've got this h of x equals 2f of x. Now that looks like that might be a little bit strange here, but let's do this. Let's substitute this f of x. What is that f of x equals? Well, that f of x equals x squared. So we can actually think of it like this. H of x equals 2, and then instead of the f of x, we can just substitute in what it's equal to x squared. So it's just the x squared. We're just going to put that multiplier 2 in front of it. And the question is, how does that transform this graph? Well, first we should notice here that our this f of x right here is the same in all of these, right? So it's this dotted line, this really simple parabola. Does not shift anything. It's the h that shifts in these four. So what happens when we put that 2 in front? Well, take a look at this h right here. You see how it's the exact same parabola, it's just shifted up 2, okay? Well, how we get that is if we were to go like this. H of x equals x squared plus 2. Because if we have this x squared plus c, and that c is going to in this case be 2, if the c is greater than 0, then it actually just slides up. So in this case, it's going to slide up 2. If the c is less than 0, it just slides down. So all that does in this form right here, this h of x equals x squared plus c, this c just regulates whether the vertex and the whole entire parabola shift up or they shift down on the y-axis. So that's not what we're looking for here. So let's take a look at our g. So we've got this f of x here, and the h of x is a little bit wider. Now it's going to be similar to what we see in j, except the h of x is a little bit narrower. So I'll write the same thing here. So h of x equals, and then we'll just do this right here, a f of x. And it's going to be the same thing for this j. One of them is going to be the one we want. So what happens with this a? Well, this a, if the a, and I'll just write the a for both here, if the a is greater than 0 here, but if the a also happens to be less than 1, so it's between 0 and 1, what happens is if this will actually make it wider. So when that a is greater than 0 but less than 1, so 0.1 to 0.9, it actually becomes wider, which is actually what's happening right here. Over here for j, if the a is greater than 1, right, so it's bigger than this little bound right here between 0 and 1. This just happens to be, if it's greater than 1, so that's going to be 1 and greater, then it actually becomes narrower. So that's what's happening here. So if it's greater than 1, it's narrower, which is what's happening to the h. This right here, this is actually h of x equals x, and then you've got a plus d. You actually add something to the x before it gets squared. That's what's happening with h. So we're actually looking for it to become narrower. This h of x is more narrow than the f of x, and that's what happens when your a here, this multiplier, is greater than 1. In this case, it is 2, so that's what we're looking for. Our answer is J.